Hi, welcome to another episode of I Can Alteryx That with coaches Alex and John. I'm John. Today, we're going to cover Alteryx Weekly Challenge number 220, Hedge Detection. Let's get started. Alright, so this week we've got what's, in my opinion, a quite difficult challenge. At least it's really tripped me up. Our goal, we've been given these 17 points. I'll pull up this map. So we've been given these 17 points that define the corners of a farmer's field, or fields, I should say. And our goal is to, 1, calculate the area of the entire farm, the perimeter of the entire farm, the area and perimeter of each field, and the total length of all the hedges. But for that one, we have to account for duplicate edges. So you can see right here, from this point to this point, that edge would actually be counted twice. So we're going to need to account for that as well. And all we've been given are the corners of these fields, and it doesn't say what fields they actually apply to. So I really dislike hard coding things, but for this problem I could not come up with a solution that didn't require hard coding things because, as you can see, I'm going to call this upper left field field number 1. So we got label 1 and label 2 are the top two corners. And then the bottom two, in that same clockwise order, are 6 and 5. And that pattern holds true 2, 3, 7, 6 for the second field. But then let's look at this fourth field right here. Where is it? So we've got corner number 4. So you'd think that this next corner would be number 5. But it's not. This one down here is number 5. This corner up here is actually 16. Then the next one is 17. So there just doesn't seem to be a real pattern that we can program in here. So what I ended up doing is I'm going to generate rows. I'm going to call this field ID. And we know that there's 7 fields, because we've been told that, and we can also count them. So I'm just going to make this data set where we have 7 rows. And then I'm going to write a formula that's going to say, basically for each field ID, which of these labels apply to that field. So for field ID number 1, it'll be 1, 2, 6, and 5 in that sequential order. You don't want to go in numeric order here because then you go 1, 2, 5, 6, and you wouldn't get a rectangle. And I've already written this out, so I'm just going to copy and paste it. We'll call this label, I will give it the same name. So you can see right here, if field ID equals 1, then the string 1, 2, 6, 5. 2 would be 2, 3, 7, 6, and so on. And all I did here was I just looked at the map, and I figured out which labels came up in what order for each field ID. So now for each of those 7 labels, or field IDs, we have our string labels. And then what I did is I grabbed the text to columns tool, and I split that on the comma. So now we're going to have each row for each field in the proper order. Now there's one issue with this. The labels are not in sequential order. And a few steps from now, we're going to join this in back with the spatial data. But when we do that, the sort is going to get all messed up. So one more thing that we need to do is throw in a record ID. That way, we actually have a sequential field that is in numeric order. So that's going to be our sequential field that you'll see in a little bit here. And one more thing that I need to do is our label field right here is a string. So let's go ahead and convert that to integer because it's an integer in the original data set. Move all this down. And now we can go ahead and join this data with the original data on label equals label. I can deselect the right label, don't need to have 2 of them. And you see that now, for every one of those records, we have a record ID, a field ID, and a label. And so what I'm going to do now, and I don't know if this is totally necessary, but might as well just do it. I'm going to sort. We're going to sort first by field ID, and then by record ID. That way everything is in the proper order. So for field ID 1, you can see record ID 1234, and label is 1265. So we have our labels in the correct sequential order, so that now we can go ahead. Oh, I don't have my spatial toolkit turned on here. We'll go to spatial, and we'll do a poly build. We're going to build a sequence polygon. Source field is our spatial object. Grouping field will be field ID. Sequence field will be record ID. And you see that now when I do this, we have our map, just like that. So we have our entire farm and each individual field. So the area calculations will actually be really easy from here on out. So grab a spatial info tool, or you could do this with a formula tool, but you know, whatever. Area, square kilometers, and we'll do length in kilometers. So for each individual field, we now have our area and our lengths. So let's just compare. Field 1, we have 0.021144 and then 706 for the perimeter. And look at that. Perfect match for the field, area, and perimeter. And likewise, we'll go ahead and summarize. We will go down here, spatial combine. And we'll do the same thing. Spatial info. And we'll grab an area and the length. And now we have our area and our length. 0.244 and 2.11. Yeah, perfect. For the entire farm. Now the hard part. This is what really tripped me up for a while, is figuring out how to do the hedge length. Because like I said earlier, this line right here, all of these interior green lines are going to be duplicated. And I really struggled figuring out, well, how on earth do I actually duplicate these lines? So what I ended up doing was I went back to the original data source and I appended it to itself. And the reason I did that was I wanted pair coordinates for every possible corner pair set. So since there's 17 corners originally, when I append it to itself, there'll be 17 squared, or 289 records. And then what I did here was I identified which corners shared these lines that would be duplicated. For example, I'm just going to go back up here, it's easier to find them. Let's look at this line right here, from label 2 to label 6. So I know that the 2-6 pair represents a line segment that's going to be duplicated. And so again, I simply hard-coded this. I hate hard-coding things, but I couldn't come up with a better solution. I simply created a formula for every possible pair. So the 2-6 pair, the 3-7 pair, and so on. Make sure that they're wrapped in parentheses. And I just said, call it a match, otherwise call it null. Oh, what did I do wrong there? I forgot to give it a name. And I'll call that pair. Now you could, what I'm going to do now is filter this. And of course you could have just done that straight in the filter tool. But I don't think it's going to hurt anything to make the formula first and then filter. So we'll say where pair is not null. And so that's going to filter this down to our 9 line segments. Well, they're not line segments yet, but our 9 corner pairs that represent those duplicate lines. So the next thing I'm going to do is we don't actually have to create the lines here. I'm just going to go and grab another formula tool. And I suppose I could have done this in that first formula, but we're already here, so whatever. And I'm just going to do distance, and I'm going to do the formula st distance between spatial obj, and source spatial object. And make sure we set this to kilometers, and make it a double field type. So now we have the lengths of all of these hedges that are duplicated. So what I'm going to do here is grab a summarize tool, and I'm just going to sum up the total distance there. So this will represent the total distance of all of our duplicated hedges. So this is actually going to be, well, we got to do one more thing. Over here we have our length of all these different things, and what I need to do there is summarize that length as well. Because this is going to be the total length of the perimeter and the interior hedges, not accounting for duplicates. So what I need to do is combine these two summarized values, 5.77 and 1.83, and subtract the smaller from the larger. So I'll grab an append fields tool. Just take this browse, throw it up there. And now all I have to do is grab a formula. And I'll call this hedge length. And this will be the sum of length kilometers minus sum dist. Make it a double. Just run. And we see we get an answer of 3.94049. And if we go back to the original data set, we can see that that is the correct answer. So all we have to do now is combine our different streams here. So we've got, on this browse tool, we have our field by field data. Up here, we have our data for the entire farm, and down here we have our hedge length. So what I'll do is grab some more appends. So I will append that with the farms. And I will append again. Yeah, append again. Oops. That with this. Grab a browse. And now all we have to do is rearrange the fields and rename them to match. So hopefully I can remember how this all goes, so I don't have to bounce back and forth between this and the solution. I believe we want our what's called whole farm on the top. Then the farm's area, we'll just call this whole farm area. Then we've got our whole farm perimeter. I think then we had spatial or field ID, then we've got field. I feel like I'm missing something here. Maybe I'm just being blind. What am I missing? Oh, I grabbed the wrong thing. That should be that one. My apologies. So let's try this again. Make sure I get the right ones this time. So these last two are the farm values. So I had that a little backwards. I am sorry for that. This is the easy part, just renaming things. So this is whole farm area. The source length kilometer is whole farm perimeter. Then we have our field ID. We have our field spatial field. We have field area, field perimeter. Oh, and where does the hedge go? Let's make sure we get everything in the right order. Hedge comes before field number. I forgot that one. Oops. So our hedge goes up here. And we'll just call that total hedge length. And we can deselect these last two. Those are just what we did for the arithmetic, so they're not necessary for the final solution. But there we go. There is my solution. Again, I don't think it's a very good solution. It's not elegant at all. It could be made more efficient. And it's like 100% hard-coded. But, you know, sometimes you just got to work with what comes to your mind first. In any case, there's my solution to Alteryx Weekly Challenge number 220. Thanks for watching. As always, thanks for watching the video. Don't forget to subscribe to the Data Coach channel for more awesome lessons on Alteryx and all things data analytics and visualization. Follow Data Coach on Twitter at AskTessellation and follow me personally at jemery_dataviz. Thanks again.